And then we're also, of course, with any experiment, we need to talk about how we measure performance. And so here for our experiment, our error metric is going to have two parts, of course. We have the errors themselves and the magnitude of those relative to the demand, as well as the bias. And so just a small tip I put in here in an SNOP process, I hope that you're measuring the forecast bias as well as the error, because the bias is such a critical part, specifically for supply chain when oftentimes the cost, and I'm sure you can attest to this, Roei, the cost of over and under bias can oftentimes be very different depending on the industry and the product. So
by the way I see bias is a quick win, because you could be at 90% forecast accuracy and you would feel, wow, I'm amazing, I'm the man. But in reality, if you see that you have 7% or over forecasting, or I mean, it's something that you can make minor adjustments and to achieve a huge impact. So you just need to measure this so important KPI bias.
Yeah, absolutely. And then in here we kind of have just the definitions of both WAPE, which is weighted absolute percentage error, and bias. These two, amongst demand planners, amongst machine learning practitioners in the supply chain domain are largely seen as like a bit of a very strong standard to measure your forecast accuracy. So here we have just a table, and I've went ahead and shown how we could calculate these just so you could see.
So Jeff, wait a second. Before you get into the table, I'm speaking now in behalf of our audience. Most of our audience, the forecast accuracy metric, or the forecast error basically metric, the most popular one is MAPE. I have a lot of things to say about MAPE. I'm not a great believer in MAPE. I think it's a very, very bad KPI. But I would like to hear your opinion. Why didn't you introduce MAPE here and you went for the WAPE and not MAPE?
Yeah, no, that's a great point. It's funny because I totally agree with you. MAPE is not really the best. Oftentimes, not to get too much into the technical mathematical parts of it, but it biases a under forecast, and so it will oftentimes reward under forecasting. On top of that, you can have just very distorted views of what the MAPE might be, because it has the tendency, essentially, in the way the denominator is shaped. It can blow up, it can be 1,000,000% or something when you're like, oh, well, the forecast wasn't that bad. So there's things about MAPE that just make it less than desirable. And you can kind of think of WAPE as, it's more, I guess it's more suiting and fitting counterpart to give you that same interpretability, but avoid a lot of those issues. And furthermore, too, obviously, it goes without saying, and I know you know this, but just with any supply chain, you do need to choose your forecast error metric carefully, because there is no one size fits all. This is the best and everything else is the worst. So that's just a tip as well. But oftentimes I found too, talking to supply chain leaders, I'll talk to them and I'll get, say, an Excel sheet with how they calculate their metrics. And they might say, oh, we use MAPE, but then the formula is actually what I'm defining here. And it's like, oh, well, technically that's not, it's not the same.
It's very similar, but it's not the same.
Right.
By the way, in my eyes, it's not like criticism, but I truly believe that, what's not measured is not managed. So if you measure MAPE, where to go? It's already a good start. It means you have some room for improvement, but you get a lot of value even with MAPE, right? 50% of supply chain professionals, they don't even measure focused accuracy.
It's really funny you say that. So at the demand planning practice I was at, to keep everything anonymous. I mean, it was a $9 billion retailer here in the US, and they did not track forecast accuracy. So that's really funny you say that. And that was something, I was a part of their team as, like a early grad, like intern type. And that was something I was really adamant about trying to get reporting stood up for, is like, how do we even know what we're doing if we're not computing the forecast accuracy? So
Exactly.
yeah, but great point there.
Okay, so can you walk us through this example?
Yeah, of course. So this is just to start off. I mean, I pulled this table from Google. It's a very optimistic case when we have a WAPE of 7% and a bias of 1%. But overall, WAPE and bias, the way they're actually formulated is very similar. And so for example, say I want to define and get WAPE from this table. All you'll have to do is take the actuals minus the forecasts, and then you take the absolute of those. So you get the error at every time step. You take the absolute, and you will sum those up. So you take the sum of the absolute errors, and then here you'll divide that by the sum of the actual demand. And so now you get a picture of your absolute forecast error in relation to the sum of your demand. And then furthermore, from there for bias, it's very, very similar, but you now don't take the absolute transform. So instead of taking the absolute, this will kind of show you, okay, in relation to the average, how far are you above or below your forecast? And so we see this forecast, for example, has very low WAPE, which is good, right? That's great. Sum of absolute errors is 19 divided by the sum of demand, which is 265. And then from here, the bias is less than 1%. And the reason for that is because some of those errors will cancel each other out when we sum them up without the absolute. So that's the general intuition. And it's a great metric. Like you mentioned, these are great when paired together. Oftentimes for supply chain leaders, I'll suggest something like this, WAPE. And then you say, okay, if you want one combined score, you just take the WAPE and then subtract the absolute bias. And so now we could say, oh, this has a total score. In our case, we would have you would add the absolute bias. And so in our case, we would have a total score of 8% because we have a 7% error plus a 1% bias. So now we say, okay, we want to get this score as low as possible. Right now it's at 8%. What can we do to move the needle?
Minimize.
Yeah. So
by the
yeah.
way, another metric that I recommend to use would be normalized MAPE. Basically, it looks all very similar to MAPE. It's just that you divide it by the maximum value between actual and forecast. This gives you, I would say that it normalizes your score. So it's very easy to explain, and the range will always be between 0 to 100. So you always get a good feeling of how you're doing. It's another nice metric to check, to look into.
Absolutely. Yeah. And you touched on a great property to look for when you have a percentage error metric. Is that property to be bounded at 100%? Because oftentimes a big flaw that some people can make is they might say, oh, well, we want to take MAPE and then we subtract 100 from it so we get the forecast accuracy. Well, in supply chains, that doesn't work because the errors could be larger than the denominator itself.
Exactly. By the way, this is my greatest criticism with MAPE. So basically, like if the forecast was 6 times higher than the actual demand, how can you really compute the forecast accuracy? It becomes a challenge.
Yeah, it just becomes a big mess. And
your CEO, it's a challenge.
Yeah.